Hello, hello. Welcome everyone to SIG Node's meeting on October 22nd, 2024. Today we have a couple of items, so let's get started. Beginning it off with you, Kevin.
Yeah, sorry, I'm just looking at the agenda. So this was actually, Dims was kind of calling out. He had 2 PRs he wanted to get reviewed and included in C Advisor, and I realized that we haven't had a C Advisor release in kind of a while. Like one of those PRs is for fixing the CI in C Advisor, and the other one is starting to kind of reduce some dependencies in C Advisor, but we're also main is 70 commits behind what our latest release for C Advisor is. So I wanted to kind of bring this up to kind of figure out like if we should have a release for C Advisor and start making sure we have something in place, or like what's the path forward on that end.
Yeah, I agree. There's another PR that I also want a release for that helps fix some cryo network stats that we actually definitely really need. So yes, if anyone on the call is able, especially, I mean, I think it's Google folks that are able to make releases. So I think we need someone, I don't see, no David Porter here. Is anyone on the call able to cut a C Advisor release?
I'm not sure if Dawn is on the call, but maybe we can have a discussion and see if there are gaps on the release side and if like folks from the wider community want to step up and help with the release.
Yeah, I mean, I think the main concern is I think it's write access to the repo.
Yeah. Okay. We can talk with Dawn. Yeah. Okay.
Yeah, and I think Dim's he started a thread on SIG Node yesterday. He said if there wasn't any response on that Slack, I'd bring it up here to kind of bring awareness to it. So yeah, there is already, I think there was a thread from yesterday about a couple PRs, but there are others that I think will probably need to be included soon. I think the last release we had for C Advisor was in March. So I don't know if we did one last release or if we do it every Kubernetes release.
I think it typically lines up with Kubernetes releases. But yeah, thanks for bringing this up. Maybe we can start a conversation in Slack or continue that conversation in Slack and, hopefully get someone's attention who's able to.
I'll add the link, the Slack.
Great. Okay. Moving on, Kevin, do you want to talk about swap-based eviction?
Yeah, sure.
I need to give you, as I understand it, you want to.
I have some slides I'd like to share. Yes, please.
Then you should have access.
All right. I guess Dawn is not here though. All right. Well, so what I'll show is kind of walk through the plan I have in the PR. I have a PR up for this that I've been using for testing. So for some context, for those of you on the call, we were looking to promote swap to GA in this release, and the one call out was around evictions. We've kind of have 2 problems going on. One is some users have found that the eviction manager is kind of evicting, basically it's evicting pods that use too much memory, and in swap they're trying to overcommit, and they have found either disabling or lowering the eviction threshold is their path to avoid evictions. But then what it means is that we don't really have any protection on swap. So I just wanted to give a little primer of kind of like what the eviction manager, like at a high level, what the eviction manager does is you kind of specify a signal via eviction hard, and then eviction soft is typically a grace period. And then this has a signal, which we usually have memory.available or allocatable memory.available. And then this kind of tracks a physical capacity. And then we have our summary statistics is actually used to grab both the what's available given what's available on the node actually and what's the capacity. And then once the signal is hit, we sort all the active pods and then we evict one by one and wait and see if pressure is relieved. And then this also does correspondingly set a node condition. So any new eviction support usually has a one-to-one correspondence with a condition and a taint. So for swap, the idea is that we want to introduce a new eviction signal called swap.available. And due to some subtleties around what we're actually storing in the summary stats, our capacity is really considered the physical swap limit of the node. This is actually calculated by swap available plus swap usage, because swap available in the summary stats is actually considered the physical limit minus the usage. So it's either way, the capacity is the physical limit of the node. For swap availability is the swap usage. And then what we're doing is we sort pods. We filter out all of the active pods and only include ones that have swap usage, and then we sort them in decreasing order and we evict them. This will set a node condition called swap pressure, and it also sets a corresponding taint. Yeah, so that's kind of at a high level the proposal we have. And I do have the PR up where I have been working on this to kind of make sure to test out swap pressure. I think that's all the slides I have. Just wanted to know what you all think.
I have one sort of note on that topic, which Kevin and Ryan and I kind of talked about before this, but wanted to bring to the larger group. Currently, the way that the swap eviction is working is a little bit the thresholds don't look quite right, and part of the reason for that is the discrepancy between the total swap limit and the total actually amount of swap capacity, where the swap limit on the node is just read from the total amount of swap, but actually the amount of like usable swap that pods are going to be able to access is related to the sum of their respective swap limits. And as a result of that, the eviction thresholds have to be set lower than like feels natural for like other, like if you're comparing like a memory limit, for instance, the thresholds need to be set lower than you would expect for a memory limit, because the total amount of swap that we're currently using is not actually the total capacity. It is the capacity, or like the available rather, but it isn't. It's not actually technically available to the pods. So I wanted to talk a little bit about, a world in which we had a variable amount of swap capacity in the eviction manager, and what some of the pros and cons for that might be. Like one of the pros would be the swap limit could look a little bit more like a memory limit looks like, where, you set, I want pods to start evicting at 85% usage. And then the pods themselves, if they start collectively using 85% of their limits in total, then the kubelet will start evicting. The con is that currently eviction thresholds, like the capacity field in the eviction manager is not able to, or it's not, there's no precedent for it being dynamic because there's no other resource that we allocate in this way. So that could complicate the implementation a little bit. So I'm wondering if, Don or Mernal or anyone feels as though a more accurate capacity calculation is worth the sort of the user experience improvement that it would bring, or if this first iteration of swap could just be so simple as to maybe not take that into account.
I'm not sure I got exactly. Maybe like an example would help, Peter. Like,
Yeah, well, I have this here. Let me pull up. I have this picture that I made last week that is not accurate anymore because we've sort of changed what the proposal is. But so basically, what I'm talking about is like the total full swap space is not actually the allocatable for swap because
I cannot see your screen actually. I'm not sure if others can.
let me try it again. There we go.
Yeah.
Yeah. So you see in this picture, like basically what I call the full swap space, which is the current swap max, and that's what's shown as the swap capacity on the node. That's actually not fully accessible to pods on the node because the amount of swap that's allocated to the pods is like proportional to their sort of memory limit versus the memory like max on the node. And because of that, the full swap space is not actually accessible, is like never going to actually be used. So a potential fix for that is treating this swap out node allocatable as the swap capacity, where basically if there is basically you take the sum of the total swap max of all the pods, and that's treated as the swap capacity, and then the eviction manager would use that, but it would have to be updated basically whenever you add a burstable pod, because this would like shift back and forth.
Yeah, I think with the eviction manager, like typically capacity we take to be the node limit or whatever. Like for a memory, we might have the allocatable limit, which is kind of set when kubelet is started. And I think what Peter is suggesting is to maybe that capacity can be dynamic based off the pods that you have, because they're the ones that are actually controlling how much swap was allocated for kubelet, really. And
so here's the thing, though, right? I think we talked about like separating the system from the workloads. So in this case, I'm assuming like the system slice is not swapping at all, right?
Right, but even in that case, the total amount, it's not because there are other entities using the swap space, it's that the swap limits of the pods themselves, like that's the only entity is able to use the swap. And so if the swap maxes of each of the sum of the pods doesn't equal the full swap space, then we'll never actually hit the total swap space.
This one, Don, I'll let you go for it. I think so. What is the worst case that we are protecting against? Like, we want to keep the node stable here. So if we don't actually end up using all the swap, are we just like, I mean, are we really protecting the workloads from getting killed because they are using swap? So maybe
Well,
are
that's
we being too aggressive if we use just the
right.
error
So
part?
it's actually the opposite, where if we don't have an eviction threshold that matches the like state of the node, then the kubelet won't kick in early enough before the kernel decides to kill. So like imagine our swap threshold was 60%, but only 40% of the swap could theoretically even be used. Then the pods could be swapping up to their max. And if they're using, swap plus memory amount and the node is under node memory pressure, then that pod will get killed. Whereas if we were treating the swap eviction in a similar way as we treat memory eviction, where it's like we're using the actual usable amount of swaps to go into that calculation, then setting it at 60% would mean when the sum of all of the burstable pods uses 60% of their available swap max, then they'll get evicted, and that would kick in theoretically before kills would. So you can make swap thresholds be at a point where the node, like, evictions do kick in before kill. You can definitely make that happen. It just like looks weird. Like Kevin has done a little bit of experimentation, and like on a VM that he had to set it to like 60%, 50% or something, which is much lower than you need to for memory.
It was lower than that. It was more like 10 or 20% of swap, and then the swap eviction would kick in, and it was difficult to get above like 50 or 60% swap used without a killer kind of stepping in. So like I found like there was sort of like we had to be pretty conservative on the amount of swap that we would track in the eviction before the killer would actually kind of step in.
Right. Sorry, Don, you've had your hand raised for a while.
Oh, no problem. I like that conversation. So I think we agree upon the whole thing for enable those include of the swap signal into the eviction is just purely protect syswom, right? So make sure the node still and all those the agent of all the running process is still can get that resource. So the goal it is just for the node stability. And so we definitely, because people use enable of the swap, also it is for, because there's no, for overcommitted to some extent, right? So that's why we don't want those, the or artificially kill eviction kick too earlier. So that's why we definitely need, I do think about we need to respect the system level of the signal first, then look at the swap availability, and also then we decided. So basically we only trigger off the eviction, I think, and look into the swap and the usage, all those kind of things, when we reach off the what I should say, reach off the syswom first, right? The threshold first. I don't know. This is so that's kind of we need from that perspective.
Yeah, I mean that's a good point. I don't know actually how. I think so. I don't know how the killer like if we're making we make the eviction manager aware of killer signal. Or like, I mean, it's kind of separate in my eyes where the eviction manager is sort of, we are setting thresholds below where the killer would step in so that we're actually evicting. So at least kind of what I was approach. That's sort of the approach we were taking. And so.
Yeah, I think generally, I mean, I don't, this could be wrong, but my impression was like to protect node stability, we want to prevent the killer from coming, because the killer like is not prioritizing like our sort of like way of judging what workload is the right thing to kill or not. It's just saying like whatever is allocating memory at the wrong time and is like close to its limit is going to get killed. So like having eviction kick in first feels more stable to me.
Yeah, and like the idea was we do have a separate swap threshold, and I think what the challenging part, what Peter is bringing up, is that this threshold has to be way more conservative than other ones that we have. Like for memory not available, we'll say like once we drop below 100 megabytes of memory, we'll start it. The eviction manager kicks in and sets the pressure. But for swap, I was seeing more like a 10 or 15% of swap being used would start, is kind of where I would actually start seeing like eviction. Like I can actually get the eviction manager to evict before the ohm killer has to step in. But if we start wanting it to be closer aligned with the memory evictions, it's a very different threshold. And so like I don't know if like I guess the question is more like how much swap are we comfortable with workloads using before we consider the system risky, and we want to kind of set that default. And that's what's not as clear to me, like what we're trying to aim for, because like, I think we probably agree we probably don't want to use up all of swap for kubelet, and I don't know if it's fine to set this at like a 10 or 15% of swap being used, and then the eviction manager steps in, or do we want to try to push that limit higher?
And another problem with doing it that way is also that it makes the behavior variable to the number of burstable pods and the limits on those pods on the node. Like the actual eviction versus kill is not at all related to the like pod usage, and that would make it really variable. Whereas if we made it related to the pod use, like the pod capacity, then it would make like the behavior a lot more pathological, in my opinion.
Yeah, I guess the one thought I have on the system is that like the eviction, like we do need to account for the system swap, because if we have something else other than kubelet swapping on the node, like if we're sharing this with like other types of things, they could use up all the swap, and then kubelet should be aware that there is less available. Like we can't, kubelet has to be known of the system that it's running on. So, yeah.
Yeah, I need
sorry, go on.
Go ahead. I just need a personal play with those things. I don't have any suggestion on this one.
Yeah, I guess why we're pushing it now is like code freeze is coming up, and I'm trying to understand if we should, like I have the KEP updated for this design, and I do have at least an implementation for this. But what's not clear to me is this something we should still try to target for 1.32, or do we need more time to talk about this? Because I guess the code freeze is in 2 weeks, right?
I personally think we still, once we have that eviction and people at least can try, right? So give us the feedback. Of course, we also build a stress test, and we can learn more over those stress tests, have different config and try. But I feel like different people run on a different outside of the test scenario, their own setup, maybe their own experimental setup, maybe can give us more inputs, so feedback, and then we can evolve. I don't know how, if we don't have this introduced into configurable and introduce the eviction, how people give us feedback. And the next release, you may end up have the same problem.
Yeah, I mean that's fair. I mean I have at least a PR up that implements this. So we could start there. It is implemented of what I had in the slides of a swap-based eviction using the node capacity and not being dynamic. And then I guess the main things I was worried about with trying to get this in 1.32 is it does, like, the node condition is an API object. So like, I don't know if it's like, it's kind of in the subtlety of like, this is technically an API review, because we can't introduce a swap condition without it. Well, sorry, we can't introduce an eviction signal without a corresponding node condition and taint. So, I mean, we can open it up and see if we get API reviewers and others help on that. But that is my main concern, is that, like, yeah, we do have some API parts to this that would need reviewed and buy-in from SIG Node. Like, I guess either way, PRs in the agenda. We can comment it there, and we'll see where we get to. Sorry, Mike, I see you're asking in there. So, Mike, we did have one idea of using swap IO out and in as a metric for swap, but that's not it's not necessarily something we've had exposed in Kubelet at the moment. So I think we were trying to focus on what statistics we have currently, and then like I know we have also discussed internally mostly around like PSI or swap IO metrics as another way to actually determine whether or not your system is at pressure. But those are more advanced strategies than what we're trying to propose right now. All right, thank you, everyone.
Thanks, Kevin. Great. So there's a review request in the in the meeting notes. So someone, I think, we need a I just need someone to like take a look at that. And does anyone have anything else they want to talk about? I had a quick thing which I didn't put in the agenda, but it just came to mind. The RunC 1.2.0 has finally come out earlier today. And so, but it seems DIMS had some concerns about bumping the version of the cAdvisor vendor to use it for concerns about compatibility with Containerd. So just wanted to see, just wanted to call that out. Potentially, if we don't move forward with push forward with 1.2.0, then we, might slip again on PSI metrics and other stuff. So I opened up a conversation in the Containerd dev channel in CNCF Slack to see if maybe bumping the RunC version in Containerd 1.6 and 1.7 would be amenable. So if people want to chime in there about their various thoughts on all of these different versions and these different projects, that would be great. But we've been waiting a long time for this, and I would love to see some progress in PSI metrics. So from my perspective, the sooner we can get sort of forward movement, the better.
I guess, Peter, I'm missing a conversation around, like, I know libcontainer, there's also a lot of conversations going around kind of getting rid of the RunC dependency in Kubernetes. These seem to be kind of somewhat related. Is there, like, I don't.
Yeah, so yeah, for some context, there has been another issue that DIMS posted, basically proposing that we move to use the Containerd cgroups package instead of the libcontainer cgroups package. and there was some conversation on there. It seems we have come to agreement to keep using the libcontainer cgroups package, but move it out of runc. Basically, part of the motivation there is like the runc folks don't have the same priorities that the Kubernetes team does. But they have, but we're using their code. And because of that, we've waited a long time for runc 1.2.0, as well as other sort of vendor fixes and stuff, because our priorities are different. So the hope is that making the cgroups library an actual library, pulling it out of runc will allow us to sort of package it at a different cadence, and this would save some of these issues. I think this containerd consideration is similar, orthogonal sort of though, because the ultimately the underlying cgroups package was the sort of incompatibility between cAdvisor and containerd that originally sparked Sims wanting to wait on bumping runc to 1.2.0. So it's like definitely related. And in the future, we'll probably have similar conversations with the libcontainer cgroups package that we end up using, but it's slightly different. It's from this right now, because we're not moving the cgroups package. We're just we're talking about bumping the vendor now and moving to a different library version in the future.
Peter, do you happen to know with runc 1.2 implements 1.2 version of OCI spec, or with some additional things like post 1 or 1.2 in spec?
That is a good question, and I don't know, but I'm just taking a look now, seeing if I can see quickly, but I don't know off the top of my head. I don't know if Mernal does.
I don't think they are like version tied, Sasha, but if you, I think we can check which version was rendered into 1.2.1 to know.
It looks,
1.2.0
yes,
to know which
it is
one.
using
Yeah.
1.2.0 in the runtime spec.
Okay, good.
And I think for what it's worth, there's a discussion kicked off among the runc maintainers on how we want to do releases, like a timed release or something. So once we reach some conclusion, I'll come back here.
I don't see the huge concern, but still, can we send Peter, maybe can you send an email to the Kubernetes dive and make everyone knows that, at least from SIG Node perspective. And there's perspective we should send to, at least do our due diligence, right? So as the community, and let people know.
Yes. Yeah. Specifically notifying people about the potential library change.
Mm-hmm.
Yeah,
just that
I could do that.
Style, and then at least we just say, okay, we did cover, so inform the community as early as possible. If you have something, we speak loudly now, and
that's a good idea before we start doing any of the actual work on it. Yeah, good call. I'll do that.
Thanks, Peter. Yeah.
Yes. Great. So yeah, I still continue to not see any more agenda items. Did anyone have anything else they wanted to talk about? We can.
I will follow up on the cAdvisor part. Yeah. Sorry, I had to join.
Cool. Thank you.
Yeah, late. Yeah. Okay.
And I'll post some links and put some details into the agenda notes. I didn't come prepared, so I haven't done that yet, but so that you can quickly find those conversations.
I added the Slack to the agenda, Peter, already. So the links for the discussion are on there.
I saw that to cAdvisor. Yeah, thanks, Kevin. Yeah.
Cool. All right. If that is that, then we can adjourn. Thanks everyone for joining, and we'll see you next week. Bye-bye now.